All right, so this is section 4.4, calculus 30. Question number 14, optimization problem. It says this: a rectangle is inscribed in a semicircle. So inscribed means it's inside, and not only that, but the vertices would be touching the circle. So other such rectangles would look like this. That's inscribed as well. And you maybe have a tall, skinny one that, would be like right about here, okay? So those would be inscribed triangles. And what we're looking for is we're looking for the largest area for such an inscribed triangle, okay? So the question is, would this have a large area, so sort of short and wide, or skinny and tall, narrow in the bottom and tall? Would that have the largest area, or would something in between have the largest area? And you can kind of see visually that probably something in between is what we're going to look for. Now, how do we find that? Well, again, with optimization, we're going to use derivatives, which in essence are limits, to try and allow the dimensions to change such that we're going to get a maximum area. So it's almost like letting the dimensions slide, okay? They get taller, get narrower, or wider, shorter. So the dimensions are allowed to kind of like slide until we hit a maximum area. And of course, how do we do that? But we want to create an equation and then make a function that represents the problem, and then take the derivative, because that derivative, if we can find a local max for that derivative, that means that would be the peak of the area function, and that would represent our max. So that's the big picture again. So if we follow all of our steps, what we do is we take a look at the information in the question, and you're going to see that we have some information here that the semicircle has a radius of 2, and it's on the diagram there. That means that from the center here all the way to the edge is 2. Also, that radius extends everywhere else, which would also be, this is very important, this is also 2, okay? All right, so now we've got something that's kind of important. Now if I let my quantities, let's say I have x and y, okay? So let's use x and y. So let's say that x, because I can see that I have a right triangle here inside here. So 2 is the length of the hypotenuse of a little right triangle that I can draw inside here. Now why is that going to be important? Well, because this side length I could let equal x, and this height of this little triangle I can let equal y. And x and y can also be used to give me an equation for the area of the triangle. So often Pythagoras, perimeter, all that sort of, like something, often Pythagoras can be used to kind of generate this other equation. So x is going to be, this half the width, let's say. So let's say 2x is the width of the triangle, okay? 2x is going to be the width of the triangle. There's x, here's another x, you see that? And then y is going to be the height of the triangle, did I say? I meant rectangle, height. Okay. All right, so from this, I have 2 pieces of information. I have the fact that I've got the relationship here between x and y, and 2 is Pythagoras. And I can also now build my area function with the x's and y's here as well. So I can use x's and y's all over the place here. So my area function that I'm going to focus on here soon is going to be 2x times y. You see how that's the area of this? And that is what I'm going to try to maximize. So the largest area of the triangle, there's the area. So this is what I'm going to do calculus on. But I notice that I have 2 variables. I just want one. That's where now I go back to Pythagoras and I say, you know what, I know that x squared plus y squared equals 2 squared. Awesome. That's awesome. So what we're going to do is we're going to solve for one of these variables and substitute. So I'm going to solve for y. So that's going to be 4 minus x squared on this side, and then square root. Don't worry about the negative version of this square root, because we're dealing with a distance of y, so positive is all we need. The other thing is, please don't fall into the trap of taking the square root of this and saying that that equals 2 minus x. Okay, it does not equal that. So please don't do that. And that's because if you were to square this, you don't get 4 minus x squared, right? You get 4 minus 2x plus x squared. So don't fall into this trap. Students sometimes still look at this and say, oh, 2 and x, no problem. but it's not that way, okay? So you do have to use the root there. Capiche? Good? I know it's early in the morning, but hopefully this is making sense. All right, so now in blue, let's take a look at our combined area function now. So now I'm going to put this in for y here. So area is going to be 2x times root 4 minus x squared. So just a y, one single y, 2x, y. Okay. All right. How are we doing so far? You guys with me on this so far? Okay, don't even need the brackets there, but we've got, we're good so far, yes? I'm seeing some nods. Yeah, okay. All right. Now, you got to be careful with this, okay? This is going to be product rule.
Attention students, teachers, and staff.
Okay, so this is a product of two functions. There are two x functions. There's a 2x. If this was just a 2, then if this was just a 2 here, then not a product rule. Don't need a product rule. But because we had an x here, right? Because we have an x here, then that's a big deal. So put that 2x back in there. So we have to do product rule here, okay? Product rule. So we're gonna, this is a function of x now, so that's great. Area prime, you don't have to put the bracket x really. I have been just to say, hey, we've got only one variable, so this is gonna be good. You don't have to put bracket x here if you don't want to anymore. I get it. You can just do a prime, it's fine. But we're gonna do product rule. So derivative of the first times the second plus the first times the derivative of the second. So that's a 1/2, remember? That's a 4 minus x squared to the 1/2. And so that's going to be 1/2. 4 minus x squared, we leave all that alone, and we subtract 1 from that, so that's a negative 1/2. All right, so that's a bit more of a complicated derivative in these questions than we've seen maybe so far. But all the rules stay the same. We're going to try and simplify this if we can, and of course I do see a 2 and a 2 there that can simplify. Oh, times. I've just noticed we got to do something else here. So derivative of this second one, we have to multiply by chain rule. So negative 2x here. Yeah. Is that what you were going to say? Your hand went up there? Yeah, I saw it at the same time. So a little bit more complicated than what we've seen still so far. But the rules will stay the same in that we have to let this now equal 0. So we're going to do some simplification, which would include, I would probably put, make this a positive and put this down in the bottom, make it a root. So let's just simplify this a little bit and see what we can do. So I've got 2 root 4 minus x squared. All this mess over here, these 2's do cancel out. I've got an x squared, so I've got a negative 2x squared, looks like. So minus plus a negative 2 or a minus 2x squared on top. And on the bottom I've got root 4 minus x squared. All right, so again, to let this equal 0, might want to get this into a single term. So we might want to actually do that subtraction, which would mean we'll get a common denominator. So a single term is better than this 2 terms. You're going to have to kind of do it anyways. So I would probably work on that first. So to get a common denominator, I'm going to have to multiply top and bottom by root 4 minus x squared here, which is really going to make root 4 minus x squared times root 4 minus x squared. So that's going to be a squared. That is going to cancel off with that. So what we're going to have is we're going to have 2 times 4 minus x squared minus 2x squared all over root 4 minus x squared. Simplifying that, it's going to be 8 minus 2x squared minus 2x squared. Nope. Yeah, plus minus. Let me double check that. It's minus. Yep. So we've got 8 minus 4x squared on top. And we can factor that to now or later. So, okay. So we're going to let this equal 0, and we're going to solve. So let's bring that over here. So we're going to try and solve for x here. And again, if you have a denominator, So where this whole thing equals 0, where it equals 0, is where the numerator equals 0, right? This being, like, there's no number that this will equal that will make this 0, right? No. Yeah, so like if this was 0 on the bottom, we'd have a problem. So that's a restricted value. And any other number would not make this 0. So generally, if you see some kind of fraction, right, or some kind of rational function equaling 0, just focus on the top. And you could think, well, let's multiply both sides by root 4 minus x squared, and then you get rid of this, and then it's still 0. So you're just focusing on the top. So wherever the top equals 0, keeping in mind that we have a restricted value here of 2, right? Plus or minus 2. So plus or minus 2 is not going to be a good idea. So we'll keep that in mind that that's going to be a problem. But let's see what we got here. Okay? So 0. Now, actually, I guess we could take the 4x squared over this side. Equals 8. Divide by 4. X squared equals 2. So x equals root 2. And again, we're dealing with lengths, so don't worry about the minus or the negative here. It's just positive root 2. So x is root 2, and that's totally fine. That's not a restricted value or anything. Okay, you with me so far? Any questions about this? All right. So what that means is that when x equals root 2, that's going to give us the largest area. So I need to find my dimensions now that go along with that. So root 2 plus root 2 is the width, and we'll figure out why. So if x is root 2, the width is 2x, or 2 root 2. So the width is 2 root 2, and the length, y, so what do we say y was equal to here, right? Up here, 4 minus x squared, root 4 minus x squared. So root 4 minus root 2 squared. 4 minus 2, the squared and the root cancel out. So y is also root 2. Same as x. So the dimensions would be, 2 root 2. Is there units involved here? Centimeters maybe, or centimeters? Okay. So 2 root 2 centimeters by root 2 centimeters. Okay, these are the dimensions. And if the question asks for what is the area as well, so, it says find the largest area. So the dimensions are not really part of the answer. The actual question says what's the area. So area is 2 root 2 times root 2, or 2 times 2. So the area is 4 centimeters squared. Length times width. Okay, so I can get that all on the same screen. Probably not. Make it super small. Yeah, that's not going to work. Okay, so that's 14. We have a similar question on your graded assignment that's coming up there. Does that help? Answer your questions there? Okay. Yeah, so that's probably the most complicated one that we've done together here so far. So maybe one's kind of like that on your assignment. Okay, good.